Probability shapes your life far more than you realize. Every choice you make, every risk you take, every moment, something feels lucky or unlucky, there's a pattern beneath it. And once you understand that pattern, the world becomes clearer. Decisions become easier, and randomness becomes less intimidating. In this video, we're going to break probability down into simple ideas you can understand immediately without formulas or heavy math. Just everyday logic, clean examples, and a new way of thinking about chance. Luck feels mysterious. It feels personal. It feels like something magical that decides when things go our way and when they don't. But underneath all the stories we tell ourselves, luck is really just math we don't notice. Probability is the language of uncertainty, the tool that helps us understand chance risk, and the patterns hidden inside randomness. Today, we're going to break probability down into simple ideas, intuitive examples, and everyday logic. No formulas, no complicated symbols, just the story of how chance really works and how understanding it can change the way you make decisions. Let's start with a basic question. What is probability? Probability is simply a way to measure how likely something is to happen. A coin flip has a 50% chance of landing on heads. A six-sided die has a 1 in 6 chance of landing on any particular number. A storm might have a 30% chance tomorrow. And a lottery ticket has a tiny chance microscopic of winning. Probability doesn't say what will happen. It tells you what can happen and how often you should expect it if you repeat the situation many times. It's not about certainty, it's about likelihood. But before we talk about different kinds of probability, we need to talk about randomness. Randomness is the idea that even if you know everything about the setup, like flipping a coin, you can't predict the outcome of one single event. You can only predict the pattern that emerges over many events. A single flip is unpredictable, but 1,000 flips are very predictable. Half heads, half tails, very close to 50-50. That brings us to one of the most important ideas in probability, the sample space. The sample space is just a list of all possible outcomes. If you roll a die, the sample space is 6 numbers from 1 to 6. If you pull a card from a standard deck, there are 52 possibilities. If you buy a lottery ticket, the sample space might be millions of combinations, which is why you almost never win. Understanding the sample space helps you understand how likely any particular outcome is. Probability is simply the number of favorable outcomes divided by the total number of possible outcomes. You don't need formulas to see this. If a bag has 4 red balls and 1 blue ball, there are 5 possible outcomes, and 4 of them are red. So the chance of pulling a red ball is 4 out of 5. Now let's talk about one of the most important ideas in probability independence. 2 events are independent if one of them doesn't affect the other. Tossing a coin twice gives you independent events. The result of the first toss has no effect on the second. Many people fall into the gambler's fallacy, the belief that if you keep getting heads or tail, must be due, or more likely next time. But that's not how probability works. Each coin flip is a fresh event with the same odds. If you flip a coin 5 times and get 5 heads in a row, the chance of heads on the 6th flip is still 50%. Your emotions change. The math doesn't. But not everything in life is independent. That leads us to conditional probability, the probability of something happening, given that something else has already happened. Conditional probability is something you use all the time without noticing. The chance of rain is higher if there are dark clouds. The chance of drawing a red card may change after one card has already been drawn and not replaced. The chance of someone being sick increases if they're in close contact with someone else who is sick. In everyday life, many decisions are based on conditional probability without anyone calling it by its name. Now let's talk about something that really shapes outcomes: expected value. Expected value is one of the most important concepts in probability because it helps you understand long-term results. Expected value doesn't predict what will happen once. It predicts what happens on average if you repeat something many times. Casinos use expected value to guarantee profit. For example, if you play a game where you can win $10 or lose $10, but the rules slightly favor the house, your expected value becomes negative, meaning the more you play, the more likely you are to lose money over time. This is why casinos always win in the long run, even if a few people win in the short run. Lotteries, slot machines, roulette. All of them are designed with a negative expected value for the player and a positive expected value for the house. Once you understand expected value, gambling looks less like luck and more like a business where you're the customer and the product is hope. Probability also plays a huge role in risk. Risk isn't just about the chance something happens. It's the chance multiplied by the consequences. A 1 in 1,000 chance of something tiny happening is no big deal. A 1 in 1,000 chance of something catastrophic happening might be huge. We use probability and risk when we buy insurance, when we invest money, when we decide whether to take a medicine, and even when we choose which route to take home to avoid traffic. One of the most powerful ideas in probability is the law of large numbers. The idea that the more times you repeat an event, the closer the results get to the expected pattern. Flip a coin 10 times, and you might get 7 heads. Flip it 1,000 times, and you'll get very close to half. This is why casinos don't care if someone wins big once. Over thousands of players and thousands of games, the pattern always returns to the expected value. And now, we reach one of the most surprising mistakes people make: the gambler's fallacy. The gambler's fallacy is the belief that past events affect future independent events. For example, if a roulette wheel has landed on black 5 times in a row, many gamblers think red is due, or more likely next. But the odds are the same every spin. The wheel doesn't remember. It doesn't know what happened before. Only humans keep track of streaks, and we tend to imagine patterns where none exist. One of the most famous probability puzzles that reveals how counterintuitive chance can be is the Monty Hall problem. Here's how it works. You're on a game show. You choose one of 3 doors. Behind one door is a prize. Behind the other 2 are empty spaces. You pick a door. Then the host opens one of the remaining doors that he knows is empty. Now there are 2 doors left, the one you picked and one other. Should you switch, most people think the odds are now 50-50. But switching actually doubles your chances of winning from 1/3 to 2/3. That's because your original choice had only a 1 in 3 chance of being correct, and the host revealing an empty door transfers the remaining probability to the last closed door. It feels wrong, but it's mathematically true. Probability often reveals how unreliable our instincts are when it comes to randomness. But probability isn't just about games and puzzles. It's woven into your everyday life. When you choose a route to avoid traffic, you're calculating probability. When you compare 2 medical treatments, you're thinking about probability. When you save money in case of emergencies, you're planning for unlikely but important outcomes. When you read weather forecasts, check product reviews. Decide whether to take a risk or evaluate an investment, you're using probability, even if you don't realize it. Understanding probability helps you see the world more clearly. It helps you think in terms of likelihood instead of certainty, in terms of patterns instead of guesses. It helps you avoid bad decisions, unrealistic expectations, and dangerous assumptions. Probability doesn't remove uncertainty from life, but it transforms uncertainty into information, something you can use. So let's step back and summarize the big ideas. Probability measures how likely things are to happen. Randomness exists, but patterns appear over time. The sample space helps you understand all the possible outcomes. Independent events don't influence each other. Conditional probability adjusts the odds when you know new information. Expected value tells you the long-term average outcome. Risk is the combination of probability and consequence. The law of large numbers explains why long-term patterns stabilize. The gambler's fallacy warns us not to imagine patterns in randomness. And probability shows up everywhere in decisions, predictions, finances, science, and daily life. Once you understand these ideas, the world becomes less confusing. You see the structure behind uncertainty. You understand that luck is not magic. It's mathematics filtered through everyday life. Probability doesn't control your life, but it helps you understand it. And the more you understand it, the better your decisions become. That's probability explained simply. Probability doesn't predict everything, and it doesn't remove uncertainty from your life. But it gives you a powerful lens to understand how chance works, how patterns emerge, and how risk can be managed instead of feared. Once you grasp these ideas, you'll start seeing probability everywhere in finances, in health decisions, in games, in conversations, and in the way the world unfolds every day. It's not about controlling luck. It's about understanding it. If you enjoyed this simple, story-driven explanation and want more videos that break down complex ideas into clear, intuitive insights, feel free to subscribe and explore the next topic with us. Until then, stay curious, because understanding probability means understanding the hidden rules of everyday life.